Trusted your word, believed in your quest. Now I see though, just like all the rest. Trusted your word, believed your lore. Now I see through, can't trust you no more. Psychologically abused since I was a kid, believing your stories, the things that you did. Now I'm asking for my money back. I have it tallied up, 800,768 fiat dollars. Gave you my trust, followed your way. Now I see though, deceit on display. Now say you've been lying to me. Lies and deceit, it's all I see. Now so you've been lying to me, but deception's a game you played every day. Lies and deceit, it's all I see. NASA, you've been lying to me with your fake streams and false reality. NASA, you've betrayed my trust with your fake streams. Stop being blind, admit your unjust lies. Since I was a kid, you fed me lies, stories and fables. Now I realize, meant for the masses to be force-fed to the blind. NASA, you've been lying to me with your fake streams and false reality. NASA, you've taken my trust through your lies and deceit, turned it to dust. You've taken my trust through your lies and deceit, turned it to dust. Trusted your word, believed your lore. Now I see through, can't trust you no more. Gave you my trust, followed your way. Now I see though, your deceit on display. Now say you've been taken from me. Lies and deceit, it's all I see. Now say you've been taken from me, believed in your quest. Now I see though, just like all the rest. Trusted your word, believed your lore. Now I see through, can't trust you no more. Lies and deceit, it's all I see.
Welcome, lads and ladettes, to Aether Roundtable number 90, an Aether Physics peer review of Inductica's recent video. Thank you for joining us.
Thank you for that awesome intro. So last week I was watching Inductica's latest video, and I thought it was an awesome piece of work, and I wanted to share it with all my friends and get their thoughts and opinions on it. And some of them thought that it was awesome, so they took some notes, and we're going to watch through it, have a little watch party, and go through the logic and reasoning steps that he put forward to build his framework. And we're going to give some critiques and feedback and talk about the interpretations of some of the experiments that are supportive of what he's trying to put forward. But before we get to that, we have a special announcement. Everyone that bought merch, thank you guys so much. The merch just shipped out today. If everything goes accordingly, you should be getting it on Saturday. So, probably Saturday or Monday is when you guys will be getting that. Friday is a holiday or whatever over here. So, with that, I think we're good to go ahead and begin.
Want me just to start playing? Everyone watching?
I'm in.
Yep.
It's not in. Let me see.
Oh, can you play it at a lower frame rate for me, please?
Yeah, you're at 60 right now.
Oh boy, 30 frames, 720. I'm at 2K, so we'll do 720.
Yeah, thank you. Elon Musk almost called Stone.
All right, let me go. Volume
What
check.
are you doing? My satellite just caught on fire, bro.
I'm sorry, I don't know what I was thinking, dude. That's on me.
Recorded version of the lecture that I gave in
This is
Munich,
it, right?
Germany.
It's the right video?
Yep,
Okay.
that's it.
At the Conference for Physical and Mathematical Ontology. My goal today is to arm you with a new weapon of science. an
So real
ancient,
quick,
forgotten weapon.
pause. So Gally, since Zave is, we're still waiting on him, but if at any time you want to like, have Shane pause and go over anything or point something out, just you have the floor, sir. And same for you, Stein. Anything there?
Oh, well, this is going to take a long time because I have things all the way through, starting
Okay,
at a minute in.
Oh, well, I mean, that's what we're here
I
for.
could just, we can cover them all the way through. That'll be just fine. I'll just yell pause. Okay, go for it.
Yeah,
Used by
throw
the
up
great
white flag or whatever.
I'll just double tapping my space bar continuously tonight. It'll be fine.
scientists of old to conquer
Bitchin'.
the physical world. Let's understand a superior version of the scientific method here on Inductica. The problem. Mainstream physics is flawed in both its content and method. Its theories are marked by floating abstractions, quantum non-absolute properties, space and time flowing into one another, and there's very little interest in what these abstractions physically mean. This is the instrumentalist view of science. The idea that it doesn't really matter if we understand what's going on under the surface of physical phenomenon, as long as we have a theory that can recapitulate the observations, that's the best that mankind can ever do. And what this really
right there.
amounts to
I dig it already. This is great. Talking? No, nobody told me to stop. I just stopped it. Okay.
Nope,
Oh, I'm sorry. I
Oh.
had the mute button set on there. Standard noob. Okay, yeah, no, I agree up to this point when he's talking about the way that mainstream has really set the bar quite low in regard, for scientific standard in treatment of what is fact and what is assumed. And I would commit that to everybody's top of their mind as the theme as we're about to go through this, and check this man at his own statements against what he has just said. And let's see how far we get.
is an abandonment of physics. It's a disinterest in what is actually happening in the physical world. And this is an immense tragedy, since science
Right there.
gains its power through an
Hold it.
identity.
I'm not so sure he's hitting the nail on the head here. Like, I see it more as abandonment of proper methods, but in a glib analysis, I suppose these two could be interpreted as the same thing. But I would kind of draw a line in the sand there. He's going to say one more sentence about this being a tragedy, since science has its power through an identification of new physical phenomena, not through identification per se, so much as their causal explanation, along with their relationship to other known phenomena. He goes on with, as an example, think of the power we gained by identifying the fact that matter is made of molecules and atoms. And I find this to be his first unfounded assumption, that he stepped over the line he so clearly drew a minute ago, less than a minute ago in the video time. And he's already over it. I don't see anything on the board currently which constitutes proof of just what matter is indeed made of, nor the existence of an atom. A few statements from now, he's also going to refer to the atomic theory of matter, after he's just used and applied the word fact to matter being atoms, etc., etc. So let's roll from there and see how far we get.
Identification of new physical phenomena. As an example, think of the power that we gained by identifying the fact that matter is made of molecules and atoms. Before we had this knowledge, we already knew that chemicals combined in certain ratios. We already knew how to manipulate the world of chemistry on some level. But by understanding the fundamental identity of the entities responsible for these chemical reactions, we gained the ability to customize molecules like never before, opening the doors to thousands upon thousands of new materials that have enhanced our lives in many ways. If modern
Yeah, right
physicists
Another instance right here where he's showing us how low that bar has been set. Right here, he paints this storybook account of how advancements in the field of chemistry were achieved. I'm not aware of anyone publishing information about proof of successful identification of these entities that he's talking about here. And he's going to use that word a lot real soon. Okay, hit it.
Were in charge of physics back in those days, then chemistry simply never would have identified the atomic theory of matter. Instead, what would have happened is that physicists would have continued to identify deeper and deeper, or really more and more complicated mathematical abstractions, which identified patterns between reaction ratios. And there would be no clear understanding of what these mathematical patterns meant. That is the state of current physics. And this has left us in the community for physical and mathematical ontology with an opportunity. We are the ones who are not content with floating abstractions. We know that these abstractions have real physical meaning. We are the ones with the philosophy required to conquer the ether. So what's our plan?
Okay,
Quick pause on that last
This
slide.
is a recorded version
for it,
of the
Gally.
lecture. I set up the following from
Yeah,
observation.
my one issue with
these
that last
little bits
slide is that one sentence, we are the ones, or no, we know these abstractions have meaning. I would say that we know that these abstractions should have real physical and actual meaning, not we know they have meaning. They should have meaning, but we don't know that they have meaning because they're abstractions. So I would just add in the word should. I know it's like a little pedantic thing, but it is kind of important.
No, it's a good call.
Absolutely.
This
No,
one
really.
word?
I would also point out at this point along the path here that the quote atomic theory of matter itself is a collection of floating abstractions. Just an observation.
Yeah, I like that.
Yeah, I forget where we were. My thing jumped.
Finish with we're the ones with the philosophy required to conquer the ether. After this, he's at 240.
Okay, thank you. There we go.
the ether. So what's our plan? Well, of course, our plan is the scientific method, right? Make a model, have that model make a prediction, then go out into the field and test that prediction. If your model gives a prediction that the mainstream models don't, it validates your theory. I have very bad news, though.
This is where mainstream frequently find themselves in trouble, in the legitimacy department. You know, a model which yields an unconventional, correct prediction is not automatically valid. This is where the peer review process should take over in its actual validation or refutation via replication. This is what he goes into during this video at the 3.5 minute mark. Coming right up. We're almost at 3 minutes now. Go for it.
This is going
This
to be
section
a
reminds
very
me of
hard.
when Dr. Bennett talks about. This section reminds me of when he talks about how gate-kept the peer review process can be. This entire section.
Hard road. A road that many great physicists have spent their entire lives on, have died upon, and have made no significant progress. Examples of such physicists are David Bohm, who came up with a rational theory of quantum mechanics, Heinrich Lorentz, who came up with a rational theory of special relativity, and Lajos Janissy, who came up with a rational version of general relativity. All of these men came up with rational versions of the existing theory, but failed to generate any novel predictions. And so they lived and died on this road without making significant progress. Now, let's imagine that you have some kind of novel prediction that you're.
This is where I start to just pick it apart when he's using expressions like rational theory of special relativity. Frankly,
Dude, I want to see the rational derivation, dude. Sorry, Stone.
yeah, no, I get you. The adjective that comes to mind for me is more like compensatory theory of special relativity. You know what I mean? Trying to compensate for what was found in 1887 and how there just doesn't seem to be much of a way around that other than inventing a complete new set of mathematics based on something that doesn't happen. I'm thinking more along lines that they came up with the novel. It's more along that they came up with the novel predictions. It's just that the predictions weren't valid nor ever proven during using true scientific method, and that's what he presently describes what's coming up next. So yeah, hit it, man.
You're able to surpass these giants and you're able to make some prediction that goes against the mainstream. If this happens, you are very unlikely to be funded. The nature of the way we fund physics goes against people who have novel ideas. So you're unlikely to get the money required for such an experiment. Now, even if your prediction ends up happening in the physical world, this actually proves nothing. We are the first to know that a model can be wrong while still making correct predictions about the physical world. In this picture, I've shown an example of the epicycle theory.
So this is actually really important later on in the presentation too, but he says, even if your prediction ends up being confirmed in the physical world, this actually proves nothing. We are the first to know that a model can be wrong while still making correct predictions about the physical world. That's like an underpinning of the scientific method, where you can have a model and it can be wrong even if it makes correct predictions. And then he's going to go into this cycling theory that I think he's implying that this is wrong.
It was a model where the Earth was at the center, and yet the model was still able to reproduce the correct observational positions of the planets in the night sky by making the planets go in these curlicue patterns. So just because a model makes correct predictions doesn't mean it's right. All of modern physics is a testament to this. But you might tell me, well, James, that's just how science goes. Science is hard. It takes a lot of work. I can't be expected to make progress in just my lifetime. But in the past, science did make progress in a single man's lifetime. And the reason is because there's a better way. Let me show you that better way with a simple example. Let's say that you rub a piece of glass and then you hold it over some paper and it starts picking up little bits of paper. If you do this, you now know that this tube of glass has a property that other entities don't. You didn't see the property, so how do you know it's there? You saw the action, you didn't see the property. But here's how it works. If you see an action, you can then reason that.
He makes the same kind of assumption we ubiquitously see in the mainstream. Maybe this glass only has this property when held by a human or is in proximity to a human. Many relevant tests and experiments are requisite to our legitimate application of the term known. This is proper isolation of the variable, something near and dear to the heart of Bruce McGuire, for instance, right? So coming up, prepare for many occasions where James here jumps what he then, right to what he then assumedly knows. And this also leads to problems with determination of whether something is really a fundamental principle. So let's let the chips fall.
Entities act in accordance with their actions. So an entity that acts in a way that others don't has a property that others don't. So even though you can't see the property, you immediately know that it's there. Now notice that this method I've shown you has nothing to do with guessing and checking. You know it through inference, from observations, and from fundamental principles of how reality works. Now, let's say that you notice that the cork inside of your glass tube also has this strange property. It's able to attract bits of paper. Then you might wonder, well, can this property actually move through objects? So you might set up the following experiment. You might set up a rope, charge up a glass rod, give a rod this electric property you discovered earlier, then touch it to a rope. Once you touch it to the rope, it might make this glass ball have this property. And that would be evidenced by the fact that the glass ball suddenly starts picking up little pieces of paper. Now, you could frame this as a guess and check. You could frame this in terms of the impotent hypothetico-deductive method that is mainstream right now. Okay. You could say, hey,
Hold on there, man. I think the word impotent is going a little too far. And in making this glib generalization here, I think he's taking focus away from the systemic errors most frequently committed by the mainstream in the use of deductive method. I think that would be a better, more coherent way to critique the method itself than just using the word impotent. But all right, let's roll.
predicted that the ball would get electric. So, maybe the electricity does run through the rope. But simply by reframing it, by refusing to think in terms of the hypothetico-deductive method, you can actually gain certainty about what's going on here. You can instead engage in the following process of reasoning. The tube has the electric property. If I touch it to the rope, then the tube is able to act on the rope. How do I know this? Because of the general principle that entities act at their own location. This is the law of locality. Entities do not act on one another over a distance. They can only act on entities that they are in contact with. The tube was able to act on the rope, and one piece of rope was able to act on the next piece of rope and the next piece of rope until it acted on the ball, making it electric and giving it the ability to attract paper. By framing your experiment in terms of an inference, you now know that
did the effect actually begin to take place just, quote, before touching the rope? I totally disagree with his premise that entities only interact with things with which they are in contact. You know what I mean? His method of inference is starting to look like a pretty slippery slope at this point. Maybe the electric property is only able to transfer through the rope as long as that grounded support setup C and D are also present and to some degree holding up the rope. Maybe that's also a necessary condition and he hasn't identified it yet. You know what I mean? Yeah, watch that. Okay, go.
Electric property is able to transfer through rope. What I've shown you so far are baby steps. But of course, with enough of these baby steps, each step gaining certainty about some small part of the physical world, this eventually reaches a critical mass that gives us immense power over nature. What I've shown you today, the fact that electricity can run through objects, is the core of our power grid, allowing us to transfer energy wherever we'd like with relative ease. What I've shown you here is the method of inference. It grants explicit knowledge of the nature of physical processes. Notice that we're not guessing and checking and saying, oh, well, the physical process I had in mind made correct predictions, so I guess maybe it's true. No. Through inference, you know immediately that the physical process you had in mind is what is indeed
Did you guys all catch that right there? Did you guys recognize the reductio ad absurdum fallacy he just dropped on you? Checking and guessing is like, oh, well, I guess maybe. I wonder what he means as well in his use of the expression frame the inference properly. Very auspicious language. Let her rip.
Well, but he was accusing people who do the guessing and checking as doing that. He says, notice that we're not guessing and checking and doing such a thing such as, oh, well, the physical process I had in mind made correct predictions, so maybe it's true. He says, no, we're not doing that. So he's proposing instead of that, he's saying that's absurd. What they're doing would be reductio ad absurdum.
The inference properly.
At the same time, he's talking about his process is, oh yeah, we're observing. Well, in my book, that's checking. So I'm not sure what he's trying to differentiate. You know what I mean?
Yeah, he's proposing logical inference-based knowledge building. So, like, you make an inference, you do scientific method, you justify the initial hypothesis, and then you have knowledge, you build upon that, rather than the guess and check method where it's like, we assume that this is right, and then we run experiment after experiment, which reifies the thing we assumed that was right in the first place.
Do this. And when you think about it, is it any wonder that the hypothetico-deductive method has led to a set of mainstream physicists who have a disinterest in underlying physical facts? If you can never really prove what's going on underneath the surface of your observations, then what's the point of understanding actual physical facts? I mean, the only point is just if you can make predictions or not. So we can see that the vices of modern physics...
So, real quick pause. So before he said, let me just back it up. He said, just because a model makes correct predictions doesn't mean it's right. Well, conversely, my boy, just because a model cannot or does not make correct predictions doesn't mean it's wrong. But he said, just because a model makes correct predictions doesn't mean it's right. Well, here he's saying the only value becomes whether or not you can make predictions. Is he not saying correct predictions? So not necessarily correct predictions. We assume he means correct predictions here. So why did he say before that the predictions aren't like necessary? They don't necessarily matter. You guys see what I'm saying?
Excellent point. Sure do, man.
Physics are in large part caused by the hypothetico-deductive method. Now notice that the method of inference also achieves a much higher level of confidence. We are reasoning from observations, which can be known with certainty, and we are reasoning from prior premises, which themselves have been proven through observation. And as long as we use proper deduction, we can gain a very high level of confidence in our understanding of the world that comes from this method. And of course, the method goes through first observations, deductions from those observations, and that results in knowledge that goes beyond the reach of the senses.
Yeah.
Now, when you
Yeah, sure. Sure. This is nonsense? I mean, does he mean statistical confidence? Because there can be none in a process which is done only once and never repeated. You know, the event when something is inferred. Premises
Yeah, and I just
proven
want to
through
add to this one word.
Go ahead.
Oh, sorry, yeah, again. So I thought you were done.
No, almost. It's just that premises proven through observation to me sounds a bit like Duffy and the TFE gang. And again, he just
Okay.
gets right on there with the expression proper deduction. Here he is at one moment criticizing the use of deductive method, and the next moment he is utilizing it in order to gain confidence in his inference. I find that kind of ironic, I guess.
accumulate
in
enough of these
In summary, he proposes that like we move from what he calls the guess and check science to inference, justify, reason, know. And when it comes to the word knowledge that he's using, that is a very specific definition, right? So that's when you take something you believe to be true, you transform that belief via the process of what's called justification and reason into something you can call knowledge. And that knowledge base becomes your next like foundation for the next thing. So you take the inference, that belief, and that knowledge, and then you build upon it. So it starts with the inference, then the belief, then it becomes knowledge. But one thing I really want to emphasize is that each step of the way that you take a belief, justify, reason, and build a knowledge base, you can keep track of each of these things you did. So I believe this is the case. I test it. I've justified this to be what I consider knowledge, right? Now, if we do that, we can always return back to each previous foundational knowledge claim, and we know how we got to our current justification. The heliocentrists never do this. They never know how they got to the place that they're at, where, there's some weird random claim there somewhere that they're just assuming to be true to make their model stay intact, like, I don't know, missing mass, right? Just toss that in there. They don't know how they got to that. They don't know about how some dude saw something that didn't work, it was missing mass, and he just said, oh, dark matter, it has to work, so therefore it does. That's not the same as making an inference, testing it, and building a knowledge base. That's reifying, that's affirming the consequent. So I just want to point that
Right.
out.
That's the big old slippery slope I was pointing out, or part of it at least.
baby steps. They start to build upon one another, not only so that applications become possible, but these baby steps culminate in great discoveries. What you see on the screen right now is an experiment done by James Prescott Joule. What he did is he showed that heat is the motion of molecules. How did he do this? It was through inference, not through the hypothetico-deductive method. He took a weight, he let that weight fall. He knew that the amount of work that was exerted by that weight was equal to mgh. He knew that that same amount of work would be transferred via a cable into a paddle, and that the motion of that paddle would then move into the motion of the molecules inside of the water. He knew that however much work the weight did, that was the same amount of work that was put into the water molecules, the same amount of motion put into the water. Once the water stopped swirling, Joule measured the temperature of the water and found that the temperature always rose in proportion to the amount of work put into the system. By doing this, James Joule was able to prove that heat was the motion of molecules, or at least that it was related to the motion of molecules. Now, once again, notice that he did not use the hypothetico-deductive method. He did not simply say, my prediction came true. I guess maybe I might be right. No, instead what he was able to do was this. He said, I know that there are molecules in the water. I know that the molecules are getting a certain amount of work put on them. I know the molecules will then move at a certain rate. He then showed that the amount of movement that they gave is proportional to the temperature, establishing with certainty that there's a link between heat and the motion of molecules. Now, this method that I'm showing you today is not just something that happened to work in the past. Maybe you might be thinking, okay, you've given me a lot of examples from the past, but maybe we've just come too far. We can't use this method anymore. That's not the case. We can use this now to make powerful inferences about the physical world, and I will show you one that I can do for you right now. I will prove the existence of an electromagnetic ether. After this inference, you will see that the ether will be known for sure, with certainty, not just a likely hypothesis that happens to tie a lot of different observations together. In order to do this, I will start by showing you the electromagnetic wave equation. By dissecting the physical
stuff, I'm just gonna propose to you guys. This is called a conditional disjunction. So basically, one of these has to be true. And this is about the logical inference earlier. So if modern physics or science were built on the presupposition of a background medium called luminiferous ether, then, so now we have a couple different things it could be. If it was built on that presupposition, then it still depends on the presupposition and must account for the ether. Or modern physics science claims to no longer rely on that presupposition when in actuality it does, then its credibility would be in question. Or if it still depends on it but denies the ether, then its credibility would be in question. So either it still depends on that presupposition or its credibility would be in question. I wrote this out in chat, but basically, if modern physics and science were built on that presupposition, like knowledge we were talking about before, that knowledge base, and it denies it now, you have a loss of credibility to how you got where you are. But or otherwise, I mean, it still depends on that presupposition. It has to account for it. So either it has to account for it, or its credibility is in question.
Meaning of this equation, we're going to learn something about the entities that lie behind it. So let's say we have an electromagnetic wave, and we have at each location different amounts of electric field at different locations. And let's zoom into these three locations. You see these three dots on the bottom. These are three locations that we are going to be thinking about. To understand the wave equation, we're going to have to understand that second space derivative, that derivative on the right. We need to understand what the second space derivative means. Okay, why is that? Because the second space derivative will relate to the second time derivative of the electric field. So in other words, the electric field in any given location changes in proportion to the second spatial derivative at that location. Okay, so what's the physical meaning of the second spatial derivative? Well, to understand that, let's first understand the meaning of the first spatial derivative. What I've shown here in the bottom diagram is that the first spatial derivative shows us how much the electric field changes as we move from this central location to either the left or the right. You can see on the right, there's a small increase, and on the left, there's a larger decrease in this particular example. So now, what does the second derivative physically represent? Well, if we look at this equation, we can see that the second derivative is the difference in the difference. It takes a derivative of the first derivative. It's the right minus the left, the change on the right minus the change in the left. Let's understand what that means in greater detail. I'm going to analyze an example. Let's say that on the right, the electric field's a little higher, and on the left, the electric field's also a little higher. If this is the case, then we can see that the first derivative on the right is positive. You can see that I made it positive in the diagram here. Now, the first derivative going to the left is negative. And the reason it's negative, you can see based on the signs that I've added in this equation, it's because we're taking one step backwards. The delta x is negative. So what does this lead to? If you look carefully, you'll see that this second derivative, this second spatial derivative, is a positive number in this case. Now, if the second spatial derivative is a positive number, that leads to a positive second time derivative. So what does that mean? Well, it means that if the neighboring locations have more electric field in them, then that means the central location will increase in its amount of electric field over time. Let's look at another example. In this example, the two neighboring locations have less electric field. You can see from the equation, based on the signs that I've added, and you can pause the video, you'll see in this example, the second spatial derivative is negative, and as a result, the second time derivative will be negative. The amount of electric field over time will decrease. So what's going on? What we have here is any one location increases if its neighbor has more, and it decreases if its neighbors have less. It's as though the electric field is flowing from one location to another. It's disappearing from the locations with more electric field and moving into the locations with less electric field. So let me show you one more example here. You see on the left we have a very large positive difference, and on the right we have a small negative difference. Now you can see, based on the signs that I've added in the second derivative equation, that the first term is negative and we're subtracting a negative term. However, the negative term on the left that we're subtracting is a larger number. And as a result, this whole thing is going to end up positive. You can pause the video and check the signs. This whole thing will be positive because the change on the left is greater than the change on the right. Now, if this whole thing is positive, then what does that lead to? It means the electric field at this position will be positive. It's as if electric field is flowing into the center from the left, but flowing out of the center to the right, but then the flow from left to the center is greater than the flow from the center to the right. And as a result, there is an increase at the center. Now, what I have just shown you...
Let's recap just a little bit here. Way back at the beginning when he flashed up the equation to begin with, it was weirdest the thing. He was talking about different amounts of electric field or different intensities of electric field at different locations, but he's showing a graph of the energy state of one thing, one location, 1 point over time. It's the t-squared in the lower left. He zoomed into 3 points in the timeline with no reference to location of anything, much less multiple things. So by the end of this description, I don't even know where to go anymore. All he did was he took a sinusoidal curve in one dimension and ran you through a series of explanations regarding mathematical relationships inside a wave formula and concluded that measurement points equate to entities. Therefore, Aether is involved. If you can catch that. So let's do another half a minute here, and then I'll blab some more.
Demonstrates that there is an entity at each of these locations. And if there's an entity, it means there's an ether, because it means that there's an entity at all of these locations where there's an electric field. And if there's an entity at each location where there's an electric field, that's an ether. It's an entity at each location. Now, how do we know it's an entity? It's because it has both of the characteristics of an entity. First, each of these locations has a capacity for action. What is that? That's the electric field itself. The electric field tells us what kind of action could happen at a given location. So there's something there that can act. Further, there is something there that can be acted upon. This is the second characteristic of an entity. How do we know there's something there that can be acted upon? Well, because any one location changes in its electric field in accordance with the electric fields at neighboring locations. These neighboring locations are therefore acting on this location. Therefore, there's something at this location that can be acted upon. Therefore, this is an entity. At every one of these locations is an entity. I've now proven the electromagnetic ether. My proof requires that we...
He's proven the ether. This kind of logical shenanigans is why Schrödinger got out of the business. You know what I'm saying?
Except
the only thing there may have merely been the object used to measure the field of that location, if you know what I mean. Like, the only thing there in that location, like in every location that they're talking about is a location, might have just been the object used to measure the field at that location. That would be the only thing there. There is no entity there by default until you're measuring it there and discovering that that's a location. I mean, one has to have also some regard for the ideal. In addition to regard for the practical, the empirical. This is part of the scenario considered when first developing first principle formulae in the first place, like when we're talking about attenuation of a point light source over distance, for example, with r squared. The simplicity of that formula is in how it doesn't take into account any other coefficients which would proportionately also affect the rate of attenuation, like passing through anything other than vacuum, solid, liquid, gas, plasma. The formula wouldn't presume such a thing. That would be its undoing, if you know what I mean, about the nature of the creation of a formula itself. Okay, that's the brain spew from this point. Let's go another minute or two.
My concept of an entity, so I'm going to give some argumentation for that. Again, my two aspects of an entity is it has to act at a certain location and it has to have the ability to be acted upon. Now, before I go any further, I need to emphasize that I'm not saying that this entity, whatever it is some kind of substance or material. It's not made of carbon or anything like that. It's probably not made of any material that we've ever come across so far. All I'm saying is that it is an actor and a reactor. It's an entity. There's a reason I'm using such a generic term. Now, we know this is an entity because this standard, these two criterion, are the standards you've been using your entire life to determine if something is an entity. So for example, you know that a person is an entity because they act in certain ways. They reflect light, they emit sounds, they move around, and they can be acted upon. If you throw a tomato at someone, they will change. Why? Because the tomato acted upon them and maybe made them very angry. This is also the standard on which you would...
He's drawing a parallel. If this, then that, then just this metaphor. If this metaphor is correct, then so is my scenario. And I'm going to add one. I'm going to talk about light radiating outward from a point source equally in all directions in a complete vacuum. And the equation you use to describe that in its simplicity yields the precise attenuation curve that we actually see, that the field attenuates precisely according to the predicted rate, then nothing else acted on that wave. No other entities are identified in the calculation. And at this point, we see how far into the philosophical James is going here. What he does not address is whether, quote, matter needs to physically occupy a certain part of space in order for the wave to register as at all manifested, if you know what I mean. Just to draw another metaphor on top of a metaphor. All right, go for it.
Identify something as not being an entity. So for example, if you see a TV character, then the TV character acts, but you'll notice that you can't act on the TV character. If you throw a tomato at the screen, the tomato will act on the screen, but it won't act on the character. The character will continue acting as he did before. If you threw a tomato at someone and the tomato simply passed through them, then you would entertain the idea that you're actually dealing with a hologram or a hallucination, not a person, not an entity. Why is this? Because the thing acts, but it lacks that second capacity of being able to act upon it. So this is the standard you've been using your entire life, and the standard that you use in science when you decide that something is an entity. To deny that these objects are entities, you'd have to deny that other things are entities, that salt shakers are entities, that the food you're putting in your mouth is an entity. Because the standard on which you identify something as an entity is that it acts at a certain location and it can be acted upon. Now notice that
I would point out that in order for him to truly prove his assertion to be true here, he would have to cite something which is both not matter and still satisfies his two criteria. And I haven't seen that. And if you guys have, feel free to point it out to me, please. But all right, hit it.
I know not of this matterless entity you speak of, Stone, or you consider could be a possibility. I know not of it.
Fundamental principles here. I'm not arguing from common sense. Now, what I'm saying might comport with common sense. But what's important is that this is the proper conceptualization of an entity, that this is the right way to split the world up into things that can act and to be acted upon. How do we know that's proper? Well, because it's important to tell the difference between things that can act and be acted upon and things that can't. There's an important difference between a person and a hologram. So you can see that with these broad principles and their application to the electromagnetic wave equation, we've proven the existence of an electromagnetic ether. Next,
let me just update my notes. Put the incorrect word in there. He just said they've proven the existence of an ether there using the equation and broad principles. No, he has merely related the equation to some loose abstractions, labeling them broad principles with an assertion about causality. That's actually what we just witnessed here. All right, hit it.
I'm going to use this exact same argument to prove the existence of a gravitational ether. Now, when you write out the gravitational wave equation, you get this equation. Now, this is an equation with many components, h, but if you look at this equation, you will see the same pattern that we saw in the last equation. We see the second time derivative of all of the different components of h relies on the second spatial derivative. Now this ends up being a 3D spatial derivative, but it's still a second spatial derivative at neighboring locations. So each of these h's is a different property of each location, and each of those locations changes in that property based on the value of h's at neighboring locations. Therefore, there is a gravitational ether. Now, you might be wondering...
Okay. Here we are, taking for granted way back at the start when creating this gravitational wave equation in our presumption about the causal mechanics of gravity itself. From there, we just get into way more trouble. Again, I'm really not sure he's using appropriate language when he's using expressions like is a property of each location and each of those locations changes in that property. I'm seeing need for better nomenclature in this part of the logic chain. You know what I mean? All right, hit it.
Why am I calling this a gravitational ether? Like, you already proved the electromagnetic ether. Shouldn't you just call it the ether? Why are you differentiating? The reason is because at this point, I haven't proven that these are all the same ether yet. These are different things that, so far, based on what I've shown you, exhibit different properties. They have different properties and they act on one another in different ways. So there's no proof they're the same thing. Remember, inference is not the application of common sense. It is the rigorous application of carefully derived earlier principles using exacting logic. I'm going to use this same...
Indeed. If these two things exhibit different properties, then they cannot be the same thing. Okay, aren't the two terms common sense and exacting logic? Are they not at all synonymous? How can you have nonsensical logic? Just thought I'd throw that one out there for people to consider while we're knee deep in what he's talking about here.
Argument now to prove the existence of a matter ether. If you look at the Schrödinger equation, an equation which identifies a wave that's associated with matter, you will see that the same reasoning applies. It's a little different in this case because we can see that it is the first time derivative of the property that changes in accordance with the second spatial derivative of that property at neighboring locations. And what is this property again? Like, how do you know this is a property? Well, remember, psi relates to the probability of a detection event. How does that relate to the actual properties of the ether? I don't know, but we know that psi means something physically. It's somehow related to a physical thing because it accurately predicts the probability of detection events. So as a result, we know it has something to do with some property at that location. And each of these properties change over time in accordance with the distribution of the property nearby. And so there are matter entities. There is a matter ether that acts on each bit of other matter ether at neighboring locations. Now, you might have noticed that there's a little hiccup here. The Schrödinger equation is a complex differential equation, and its solution is generally complex. It has a real and imaginary part. But I have to thank Travis Norson here. His book shows that this is just an artifact of the way we think about the Schrödinger equation. You could easily write the Schrödinger equation as a real part F and an imaginary part G. Then you can simply reframe the Schrödinger equation as two coupled equations that are both completely real. So the imaginary aspect of psi is just a mathematical convenience. It is not some indication of complex metaphysical properties of what's going on here. It's just convenience. Now, there's another argument that needs to be addressed here, and that is the fact that the quantum mechanical wave equation is not in general a function of three-dimensional space. It's actually a function of 3n dimensions. Okay, what the heck does that mean? Well, 3n plus 1 if you count time. And the reason for this is the Schrödinger equation can actually keep track of many particles all at the same time, and it needs to in the case of entangled states. And when you keep track of the wave equation for entangled states, you actually need to use one of these 3n dimensional functions. So that kind of calls into question the idea that the Schrödinger equation solution actually means anything physical. This argument can actually be overcome if we dive into the nature of configuration spaces, but I'm not going to do that in this video. What I will do in this video, though, is note that my argument still holds for the case of a single particle. If there is just the presence of a single particle, say like in the double slit experiment, then all of my reasoning still holds. This Schrödinger equation holds straightforwardly, and my argument applies straightforwardly. And what this indicates is that in the case of entanglement, there might be more going on that's interesting that we should study later. But all of that extra stuff, as interesting as it may be, is simply extra stuff that acts on top of the fact that there is a medium here, and perturbations of this medium constitute an aspect of matter.
Right.
Now that I have proven the existence of a
Let's
matter...
just pump the brakes right there, James. Right at when he says the fact that there is a medium here and perturbations of this medium constitute an aspect of matter. Okay, this is my dismount. I'm not saying there isn't an ether. I'm just saying that he could be doing a better job of allowing for the separation between that which is capable of containing matter, the medium, and that which is also ambient and may affect the way in which that medium permits the propagation of energy without being a physical part of that medium and or its function as a container. This is an issue that I've spoken on many times in recent past, and application of the simplest logical terms demands that one must allow for the probability that ether and counter space are two entirely different things. The ambient ether seems to have an alt-as polarity or orientation to it, which we've reviewed in previous papers here. Counter space seems to have a dimensionally orthogonal orientation. To it, in and out of existence, so to speak. You can mathematically represent them as dimensions 5, 6, and 7. And I kind of dream of some members of the AC gang, begin to derive equations and formulae around those new 5, 6, and 7 with respect to permeability and permittivity in the arena, particularly of electromechanics. That is like just something I could just see coming in the distance that would be splendiferous. Okay, at this point, we're just over halfway through the vid, and I think I've roasted this guy enough, so I'm just going to ride it to the end with you guys right about from here on out. So yeah, let's go for it.
Matter medium, I will now prove the existence of one final medium. I will call it the duration altering ether. Now, in order to understand this example I'm about to give you, you need to set special relativity aside. First of all, it's a flawed theory.
Okay.
Second of all, you just don't need it to understand the argument I'm about to make. And if you start applying it, it's going to be really easy to get confused. So just set all of that aside. You don't need to abandon it. You just have to set it aside and look at the observation I'm pointing to here. So the observation is going to be a certain thought experiment. Let's say you got a red ship moving to the right, at a certain constant speed. You have a blue ship moving to the left at a certain constant speed. And you have a space station here in green that is stationary in our frame of reference. And let's say that aboard each of these ships, you build an atomic clock. And let's say, for the sake of argument, that you build an atomic clock by first creating a radioactive isotope in a particle accelerator. You then attach that radioactive isotope to all the needed circuitry to build an atomic clock. You then let the ships begin floating in the direction of their velocity. Okay, now at this point, the red ship and the green space station will be right next to each other. And let's say that at this stage, the red ship and the green station synchronize their clocks. Okay, so their clocks are now at the same starting point. You then let them progress, and then let us say that the red and the blue ships synchronize their clocks. You then allow the blue ship to progress until it meets up with the green space station, and then let us compare the blue clock and the green clock. If you do this, you will find that less time elapsed on the blue clock than elapsed on the green clock. Now, in other words, the green isotope, and I want you to focus on this. Don't focus on the clock, focus on the isotopes. The green isotopes change. To focus on this. Don't focus. Green isotopes. If you conduct this experiment, this is what you will see. What can be inferred from this experiment? Okay, follow me on this. The green isotope changed more than the red and blue isotopes. What could have been the cause of this difference in the rate of change? Well, there's only one thing that was different here, and that's the state of motion of the three objects. Now, note, of course, we could have chosen a different reference frame.
The color of the ship.
To make the blue ship stationary. But however you want to frame it, there's a difference in speed here. The only thing that could have caused the difference in the rate of change of these isotopes is the difference in velocity of these three objects. And that difference in velocity is there no matter how you want to frame it. Okay, now, a difference in velocity is always a difference with respect to something. What could that something be? Well, whatever it is, it's a something that has to be at the location of the ship. How do we know that? The reason we know that is because whatever this something is, motion with respect to it is causing the difference in the rate of change. That means that something is acting on the isotope, causing it to change more slowly or more quickly. Something acting on the isotope has to be at the location of the isotope. That's the principle of locality. As a result, we know that anywhere where you can conduct this experiment, there exists an entity at each of these locations. There exists a medium, and your motion through that medium determines the rate at which these processes of change transpire. I have thus proven the existence of an ether that causes duration dilation. And I have to give some credit here to Daniel Harris. You can see a link to his YouTube channel in the description. He showed this thought experiment, and this is very similar to one of his thought experiments, so I have to give him credit for that. And of course, a similar argument to this can also be made for length contraction. Now, with a further inference, a very simple inference, we can connect the ethers. First of all, the matter and electromagnetic ether are related or the same ether. How do we know this? Well, because of electromagnetic forces. This shows that the ether is able to act on charges, and charges are matter waves, or at least they're somehow related to the matter waves. So this shows that the electromagnetic ether acts on the matter ether. Further, the matter ether acts on the electromagnetic ether. How do we know that? Well, because some matter is charged, and so it affects the electromagnetic ether. Further, we need to think about particle creation and annihilation actions. So, for example, when a positron and an electron collide, they turn into a photon. So this is one more example of the matter and electromagnetic ethers either acting on each other or just being the very same ether. Now, I suspect that if we look at some of the interactions that happen in particle colliders, we're going to be able to infer a lot more about the nature of the ether. So I think with the proper kind of work and the proper kind of reframing, we're going to be able to rehabilitate much of the data that has been gathered in particle physics and reinterpret it to make much more powerful conclusions about the nature of the ether. Let's make some further connections. The matter / electromagnetic ether is related to the gravitational ether, or it's the very same ether. How do we know this? It's because gravitation bends light and matter waves. So, the Earth, of course, moves differently as a result of the sun's pull. So that's the gravitational ether acting on the matter ether. And of course, light is changed in its path by the gravitational ether. So the
Wait, how do we know
ether
that
also-
light is changed by gravity? Is there another experiment that I'm unaware of that says that
Nope.
light?
It's just
The
that
path-
same old single slide scam from Eddington. You got it.
What happened to the make a logical inference, justify it with reason, and then you have knowledge? What is the gravity bends light? I thought he was criticizing this type of assertion, and he's just asserting
But it is known.
Oh man, it's like it's like an infestation, man. It's so hard to avoid this stuff. All right.
so acts on the electromagnetic ether. Now further, matter waves cause gravitation, so matter waves act on the gravitational ether. And light waves probably cause gravitation, so the electromagnetic ether probably acts on the gravitational ether directly. We actually haven't proven that directly through experiments.
So gravitation bends light and matter waves. Matter waves cause gravitation. Light waves probably cause gravitation. And none of this is testable, verifiable. It's just he just says it. He just says it.
Yet, but it's probably the case.
What's testable of this?
Dude, it is known.
It is known.
It is known. Okay.
It is known.
It has been said. Okay. Okay.
So what conclusions can we make? Well, first of all, there's an electromagnetic ether. I showed that with the electromagnetic wave equation and a dissection of the physical meaning of that mathematics. Second, there's a gravitational ether. I showed that through almost the exact same argument applied to the gravitational wave equation. Further, there is a matter ether. I showed that through the same argument applied to the Schrödinger equation. And finally, there is a duration dilating ether. There is an ether that when you move with respect to it, this changes the duration of certain physical processes. And finally, I have shown that all of these ethers are connected to one another. So what this does is it fully justifies the approach of certain thinkers like Dialect or Chantal Roth. What Chantal is doing, and you can see her video in the description, and I interviewed her. What Chantal is doing is she's creating mathematical models that model the ether and show what kind of medium could be responsible for all of these different interactions that are happening with one another. She is trying to find an integrated view of the ether. Now, thanks to my argument today, we can see that this isn't just a good idea because it happens to connect a lot of dots. It's right on some level. We know with certainty that it's the right kind of thing to do. We know that there's an ether. We know that all of these different aspects of the ether are connected to one another. It's just a matter now of figuring out the nature of the ether. This method of inference is going to make possible further inferences. Let me show some of them to you. So first of all, we should apply this same kind of reasoning to the Dirac and Klein-Gordon equations. The reason for this is that they are the relativistic versions of the Schrödinger equation, and we might learn more about that by moving into that context, making deductions in that context. And if you look at this equation, you can already see that it has a similar form that we're going to be able to use the same basic reasoning on. Another thing that should be on the top of our priority list is a deduction of duration and length changes to the hydrogen wave function. That is the wave function that represents the electron cloud around the hydrogen atom. What I'm talking about specifically here is trying to deduce what happens to the shape of an electron cloud when that electron cloud is moving through the ether. When the electron cloud moves through the ether, that's going to change the nature of the central potential, and it's also going to change the speed of the wave as it goes in each direction. Now, I suspect that when you apply these changes to the nature of the Schrödinger equation and the nature of the wave function, you're going to get length contraction. You're going to get a deduction of length contraction from this fundamental nature of matter. You're also going to get duration dilation in the form of a changing frequency for this wave, so it'll change at a different rate. And I think what's also going to happen is that the emission lines are going to be different for hydrogen. You're going to find different spacings between the hydrogen energy levels, and I think that those changes are going to be in line with the perpendicular Doppler effect. And so I think all of that can be explained by deductions from the
Sounds
nature
a
of
lot
this
like
wave
hypothetical
and from
deduction.
our new understanding that this wave is, with certainty, a wave of the ether. Now, Dialect on his channel has already done this to some extent, so we should continue the work that he explained in that video. He explained some of the work of Valerie Lindner, and in that work, Dialect shows us how the fields change, specifically how the vector potential and the scalar potential change in a moving frame. And he gives a plausible argument for how that's going to lead to a length contraction, a shrinking of matter, but it's not a completely rigorous argument. And I think that by making arguments from the Schrödinger equation, from the equation that really represents something about the nature of matter, we can make this completely rigorous. We can show the particular mechanism by which motion through the ether causes length contraction and duration dilation. What we also might be able to do is make some kind of deduction about changes to the inner nature of the wave function that might identify the inner mechanics of the gravitational force. That's a little speculative, but worth looking into. Now, as you go forward, I highly recommend that you start changing your mindset if you want to discover new things about the ether for yourself. What is that going to entail? First, what I'll say is that I'm not against the hypothetico-deductive method. I'm not saying don't do it. I'm just saying it's weak. It's not as effective as the kind of method I've presented today. And what you're going to have to do is to retrain yourself to search for inferences instead of thinking about ways to devise confirming experiments or predictions that go against the existing theories. You're going to need to think about ways to reframe your research. If you have a hypothesis, start thinking about ways that you might make some new observation. And that new observation is not to make a different prediction. The purpose of that new observation would be to give you that little bit of information that's necessary to finish an inference. Now, by the way, you're already doing this. You're already making inferences all the time. It's not like people don't use this method. I'm just saying that you should start using it as a matter of principle. You should use it with the same kind of regularity and careful thought that you have applied to the hypothetico-deductive method. I've painted a pretty dismal picture of what the hypothetico-deductive method looks like in practice. You guess, you check, and then even if everything works out perfectly, you still have an uncertain conclusion. So what is the path that lies before us if we choose the path of inference? Well, if we choose the path of inference, we first have to get clear on what observations and reasoning steps have been proven so far. That's really key. You can only reason from things that have been fully proven. In this video, I've reasoned from the Schrödinger equation on the premise that, well, at least it gives correct predictions about something that's happening at each location, so we can be certain that the wave function gives some kind of property there. You have to be really careful about what you use in an inference. So you have to check with great clarity what these
Like
theories
gravitational
mean that
waves
you're
or
making
whatever.
deductions from, and if you're
Exactly.
sure that they are actually correct theories, or at least if you're deducing from the parts of them that have been fully proven from observation. Now, the next step is that you're going to make inferences that prove new aspects of nature. If you get clear enough on the prior context of knowledge and you think long and hard enough about it, you will find some new ways to dig into nature a little bit further. And these baby steps, each of them is going to make possible larger and larger steps. Our end goal should be the discovery of new phenomena and new technology. This is how we're going to
that
show
slippery slope.
the mainstream that we have a better approach. It's not going to be by coming up with one more hypothesis that happens to agree with all of the mainstream predictions. So what are our next steps? What should you do today to start applying the method of inference to your own investigations. First, as I said, you have to get clear on what you know for certain and what's just a hypothesis. You then have to take your hypotheses or your models, if you've made mathematical or computer models of the nature of the ether, you have to take these models and reduce them down to what is provable. A lot of these models are mechanical analogies. For example, Chantal is working on an analogy of the ether to an elastic solid. It's really important to note that such a model is only an analogy. The ether probably isn't literally an elastic solid. Its parts relate to each other in a way that is analogous to an elastic solid. Which parts of these are analogy and which parts are real relationships? We need to strip our hypotheses to just the quantities, the properties, and the relationships between those properties that we know for certain. Only then can we start making inferences from that knowledge to identify further facts about the nature of the ether. And of course, something else that needs to be done is you need to devise new observations, new experiments that are tuned to give you that last bit of information that you need in order to complete your inference. Or in many cases, that won't be necessary. There's a lot of data out there. Maybe all that is required for you to do is to look up the data in some experiment that has already been done, and that will give you the information required to complete your inference and discover something new. And once all of these inferences reach some critical mass, that will make possible some new application. And I see this as the ultimate justification of the method of inference and the ultimate justification of approaching physics from a perspective of being interested in actual physical relationships, not just mathematical abstractions. That is how we're going to convince the world that this approach is superior. And on a final note, I think history has given us an opportunity to show the world what's possible. This isn't just about physics. You see, people once looked to Newton's method and his mechanical universe for guidance. They looked to his method as being the perfect example of logic in action, of looking at reality and knowing it. And they looked to his view of the universe, a universe of knowable mechanical objects acting on one another. They looked to that as a model for what the universe fundamentally is, a logical place that has rules that are manipulatable by man so that we can take advantage of them. But I don't think this is the case any longer. Because mainstream physics projects a world of floating abstractions and of non-absolutes, people can't use it as a role model anymore. And if this is the case, is it any wonder why politics is irrational? After all, why be rational if physics isn't even rational? Why be rational in human discourse if the core of physical reality, the thing that everything is based on, if that isn't even rational? Why be truthful when quantum mechanics teaches us that there's no objective truth to be loyal to? So I think this has given us an opportunity. If we can show the world that these theories actually mean something in reality and that they should be replaced with more rational theories, we can show the world that we do not live in a quantum irrational flux, but rather we can show them that we live in a rational, logical world that is ours to know and to explore. Thank you.
And we can do art with our shirt off.
Dude, I think he's a good lad. I think he had a lot of good ideas about inductive reasoning. He was trying to go through the right process. He just got caught up in, like, I think, as Gally said, it's hard to get away from the logical inductions inflicted upon you, right? Like, we accept the deductions which others force upon us when you start your scientific method, and things like gravitational wave in the Earth and you know, the spherical coordinate system just get pressed onto you, and he kind of lost those in the interim. But I think he's on the right path, right? He's like, hey, we can't be making basis things on logic, on mathematical abstractions, and boy, isn't all of math and physics and Einstein and relativity pretty much based on that.
No, I also give him points for you opting for the hard sell path. You know what I mean? He just laid it down, took his stance. You agree or you don't? Okay.
Yeah, yeah. A lot of good came out of this video, I think. I like this slide. He's like, look, this is nonsense. Look at the AI putting, like, melted clocks on a tree. He has a metaphor for retarded mathematical abstractions and relativity.
That's Dali. Do you recognize it?
No. Dali did. This is real. I thought it was AI. All the rest of his stuff was AI.
Salvador Dali.
Oh, that's like a
Anyways, that's
famous
the style.
artist. Oh. Oh, he did it in
Yeah,
the
totally.
style of Dali. Oh, it's still AI. Okay.
Actually, that could be one of them. I'd have to go and look to make sure.
The one he had of Einstein was definitely AI. Like we've
Oh.
used that one before, I think.
Oh yeah, there's tons of AI in this video. That's for sure.
Just to piggyback on what Shane was saying, though, one of the things he had was a fundamental postulate to have.
Better up your mic, man. Can't hear
You're
you.
very low. Wait, do I have you low?
Hold on, let me.
Maybe lean forward more.
The input is high. Testing, testing.
Sounds better.
That's a little better, yeah.
Yeah, you know, just to piggyback on what Shane was saying, the one else thing that he did is had a fundamental postulate of action and reaction, right? And he showed why that's important, giving the example of you can act upon a television show, and you know it's not an entity because it's not reacting. You know, there's a screen there. So having a fundamental postulate in the real world, I think, is one thing that's huge, right? We know about the predictive model. And ironically, he showed a predictive model that the Earth is in the center. That's incorrect. Wink, wink. But yeah, predictability. If that's not going to be your foundation, what is? And his fundamental postulate, I think that was a win of having action and reaction be important.
Yeah, it's funny that he poo-pooed the geocentric analogy as being wrong, and then went right to flashing this in the background and a speech about inferences and logical deductions. He went right from this to that, and was like, oh, okay. But yeah, but like space-time gravitational waves are proven because particles. Like, whoa, yeah, you. Nobody's perfect. But yeah, this is cool. This is a good video.
Yeah.
So on his list of ethers, I think there was 5 of them. Which one was your favorite?
Every time he broke it up into different ethers, it made me cringe a little bit.
I want to know which of those ethers is responsible for heating up my ether hot pockets.
Matter
my favorite was the time dilation and length contraction ether.
Oh, that was the worst one. Okay.
That was cute.
Duration altering ether versus electromagnetic ether versus matter ether versus gravitational ether.
Yeah,
and electromagnetic. Cute. There's 4: electromagnetic, gravitational, matter, and duration dilating.
Oh, don't forget salting my food ether.
Yes.
I do like how he accepted that the wave equation means there's not little tiny BBs of light bouncing everywhere. I thought that he made that as a foundational premise. I thought that was cool. It's like, well, obviously it's a wave. Like, that's retarded. That's a good place to start, right? What does this guy do for a living? Is he just a YouTube guy? Or is he like some science experimenter guy talking about experiments and funding and stuff?
That's a good question. I think his bio is online. Let me check quickly.
Never even looked at his page. I'm making all these inferences already. Look at me doing the thing he said not to do.
I mixed root beer with vanilla ice cream to make a root beer float ether. Delicious.
Well, that was cool.
On a serious note, though, I would like to have this gentleman on Ether Cause. It'd be nice to like sit down with him and talk about his ideas. That'd be cool.
Yeah, it would be cool.
I'll ask Steve to reach out to him. Every time Steve reaches out to somebody, they instantly join the server.
Is that what happened with that other guy? Yeah, King's Path or something. He was getting the Antarctic Sun.
Yeah. I recruited Foundering. I got him.
Yeah.
We did like the backstage event. I was like, "Oh, you were there. You were in the backstage."
Yep, I remember.
That was cool.
All right, well, I guess we'll wrap up then. We got nothing else. That was a good Ether roundtable. I appreciate all the input from the boys.
Man, I
Have you found it, Eric?
could use coffee to go along with this root beer float ether that I've got. I sure wish I had a nice cup.
You're making me hungry.
You need some really yummy iced coffee there, Gally?
Oh yeah, I could use that. Do you know of
What
any
kind
beans
though?
that I could
Yeah.
use that I could brew with and put ice in?
Yeah, the brushtail coffee is so yummy. I mean, and it's magical. That's the best part about it. Not only is it a really tasty beverage, but it does magical things. I mean, the other day we had gone to the farmers market, my friends and we were in a little bit of a rush because we had to be somewhere else. And then we just couldn't find any parking spots close by, and we were running out of time. And I was like, because I always carry a little bit of brushtail coffee with me, the coffee grinds, and in case, we need it, I need it or something. So I was like, look, brushtail coffee does all these magical things. So I just took a little pinch of the coffee from my little container and I just sprinkled it on the parking lot. And you're not going to believe it. The car that was closest to us just pulled out and left the parking lot, giving us a space there. And then as
Yeah.
it was leaving, I noticed there was no driver in the car.
I've
I
heard
mean,
similar
look,
stories. Yep.
yeah, the brushtail coffee is so magical. But, I mean, I just really drink it because it tastes so good and it just makes my mind clear in the morning. So, yep, Gally, make some nice iced coffee. Today's a good day. It's so hot.
That testimony is almost as lovely as you, Liliana, the brushtail babe.
Well, thank you, Gally G.
Very nice. Very good. All right, thank you, Lily. Your check's in the mail, as they say, or whatever.
Oh yeah, as long as you don't sue me, I don't even care about the check. But
Right,
Alan
we're
is
just
threatening to sue me.
right. So we're more of a punitive, threatening firm than a reward-based firm. I remember now. Sorry. So I think
Don't worry, I won't tell anybody that y'all keep me locked up in a dungeon making these ads.
I don't know what else.
Great, because we don't do that, right?
I mean, the more we laugh at it, the more I would think we did it. But
No, nobody's ever gonna know about it.
Good. Know about what?
so I think we got
That was a cool
maybe
presentation, Shane. Thanks for sharing. Thanks for being our pause man. Nobody hits the space bar like Shane St. Pierre. let me
right,
tell ya.
dude. It's like my finger was above it the whole time, and my finger's cramping now. So that's how quick I was responding to input. Yeah. No, I mean,
Get one of those space bars that's a space bar cut in half so you can double tap it with 2 fingers and get twice as much space bar speed.
I have a mechanical keyboard, so every key press is not only felt but heard. So
No.
anyway, we're wrapping it up then. Thanks everyone for tuning in. I think maybe we'll be around Friday. I don't know. Possibly. Otherwise, we'll probably have another presentation on Tuesday. Cool. Thanks everyone.
Welcome to the show where you don't know if it's part of the show. Welcome to the show. If you don't know, it's part of the show. Didn't they teach you to reach for the stars while opening up the bars and keeping you chained down with mortgage bills and cars? Vaccines for your arms, kids sounding like supercharged, caffeinated hate-filled scars and rage-quit repertoires. No answers for yards, caught up in emotion that's not even yours. Imposter truths like impeccable retards, lined up for your serving of gish galloping wars. No remedy can save the lost, in love with the yarn. I'm tired of walking into refracted shards, poor science displayed by disgusting bards. Soaked in sin with your dupe is delight and a new hand of cards. Been so long, seems like for love I'm just too hard, I'm just too hard, that's it. Welcome to the show where you don't know if it's part of the show. Intoxicated 8 makes you believe you're spinning in space, why you have no shame or grace. It's a disdainful state I used to contemplate, how to save myself from my own self-hate. Wonder why I was even made with a dreadful fate, forced to try and awake with a full plate, no one to help me stay awake or educate. I've had to liberate and fight through hidden gates, but my brother, heaven could never be late, and rockets don't work in space. It's all fake, the show is on Mars, it's a joke, but you're too far gone, it won't be long. Fepe's beak is strong. We have our song and we march along like streams of knowledge leading to God's holy pond, and lives of truth that hits the bong and sings the song, turns mankind from the wrong. We come in peace with a holy gown and all of us wearing our holy crowns. So the earth is flat and we probably just won't get along. Just to go along, I said, welcome to the show, where you don't know if it's part of the show.